Hello students, good morning, good evening and good night, depending on which time you are going to observe this lecture. This is the first lecture on aldehyde, ketone and carboxylic chapter. In this lecture, this is the first lecture, and in this lecture we will discuss about the very basic thing about these three compounds, and we will discuss the nomenclature and of the aldehyde and a ketone. So heading of this lecture, that introduction and nomenclature of aldehyde and ketone. Aldehydes and ketone, that we are going to discuss. This is K. Mukherjee in the Science with Mukherjee Sir YouTube channel. The organic compounds like alcohol, phenols and ethers, what we find? We find that there is a carbon-oxygen single bond. But in this compound, that is this compound that we are going to discuss, that is the carboxylic acid, aldehyde and ketone, there is a presence of carbon-oxygen double bond, and this has been represented like this way. So you can observe this is also called the carbonyl group, and carbon-oxygen double bond is present. And you can see one thing, that here carbon we know have the 4 valency. Here 2 valency has been occupied by this oxygen by giving a double bond, and other 2 bonds are free for any type of atoms. So depending on the attachment of different types of atoms, this group is going to show different types of compounds. As for example, when this carbonyl group, the carbon atom of the carbonyl group is joined to other carbon atom or other hydrogen atom, at that time we will call this is aldehyde. So we understand how aldehyde is. This carbon atom when this is joined to the carbon atoms, other 2 carbon atoms, we will call it is a ketones, right? When this carbonyl group is joined to other carbon atom and also oxygen atom and hydrogen atom, this will call the carboxylic acid. Carboxylic acid. So we can observe that all the 3 compounds is having a very common thing, that is the carbon-oxygen double bond, and which we call the carbonyl group. But the compound is not end here. You can also see the product of the carboxylic acid is like this. This is OR. This is called the ester, ESTER. And another product, another derivative of this carboxylic acid that you can see, that is acid anhydride. This is acid anhydride. Acid anhydride. When this carbon atom has been joined, C double bond O, joined to other carbon atom and halogen atom, we will call this is acyl halide. This is acyl halide. Again, this carbonyl group, carbon atom of the carbonyl group is joined to other carbon atom and nitrogen atom. We will call this is amide. So we can understand how a carbonyl group can going to create different type of compounds when we change the atoms altogether. When it is hydrogen atom and carbon atom joined to this carbonyl group carbon atom, it will become aldehyde. When there is a two carbon atom, it is become ketones. When there is a carbon atom and oxygen atom, it is a carboxylic acid. And the derivative of the carboxylic acid is ester and acetaldehyde and acetaldehyde and amide. We will discuss only the three very important compounds, that is the aldehyde, ketone and ester, carboxylic acid. These three compounds you will find as a very wide application in our day-to-day life in the biological process, and it also has application in a lot of cases that we can easily understand later on when we go to the uses of these three compounds. And this carboxylic, this aldehyde ketones has a wide application in the nature also. It gives flavor and fragrance to the nature. We are going to discuss the next part of this lecture, that is the nomenclature of aldehyde and ketones. And when we are talking about the nomenclature, this is basically been composed of the two parts, that is the one is the common name and other is your IUPAC name. First, let us understand the common name. In common name, that aldehyde. First, we will discuss aldehyde. What is the common name of the aldehyde? How do you form this common name? That can be formed from the corresponding carboxylic acid. Corresponding carboxylic acid. Corresponding carboxylic acid. Carboxylic acid. Let us understand. Suppose this is a aldehyde, HCHO, right? So its corresponding acid is formic acid. Okay? So this is formic acid. So what will be the common name of this aldehyde? That we have to replace this ic acid by aldehyde. So you can see this will be form ic acid, we are replacing that, we are giving aldehyde. So common name will be the formaldehyde. Another example is this CHO. In this case, its corresponding carboxylic acid is CH3COOH. The name of the acid we know, common name of this acetic acid, it is name is acetic acid. And so we will replace this ic acid with aldehyde to get the common name of this aldehyde. This is acetaldehyde. Okay, in this fashion we can able to have the common name of the aldehyde of the is having some substituents. Suppose, as for example, this is the aldehyde, and you can see here it is one bromine atom as a substituent been attached to this compound. And how do we able to indicate this substituent? For that we have a rule that we have to use the alphabetical words, that is alpha, beta, gamma. And now what is alpha? Alpha is the carbon atom which directly joined to this carbon atom of this carbonyl group. So this point will be alpha, This point will be beta and this point will be gamma. So what will be the name of this compound? Common name of the compound will be alpha, that is in the alpha beta position. In the beta position you can see the bromine is there, so we can write beta bromo. Then we have to see this corresponding carboxylic acid. Corresponding carboxylic acid, butyric acid. So ic acid will replace, so it will give it will give the butyraldehyde. Butyric acid, butyric acid, so we will just add the aldehyde. Okay, so we understand the common name of the aldehyde. Now we are going to understand the common name of the ketones. Now we are going to discuss the common name of aldehyde, common name of ketone. Aldehyde we have already discussed, ketones. For this common name of the ketone, we have to write the alphabetically the name of the alkyl groups present in the ketones. As for example, that is a ketone are given CH3, this is a carbonyl group, and CH3 suppose. So what would be the common name? Common name of this dimethyl ketone. Dimethyl ketone. Or we can take another example, CH3, CO, CH2, CH2, CH3. This is the name of this. See, the two groups are the alkyl groups, one this ethyl group and this is the N-propyl groups. So we have to put this in alphabetical order. So alphabetical order, methyl comes first, methyl N-propyl, methyl N-propyl ketone, right? Now for the alkyl phenyl ketone, what will be the common name? That we will now discuss. For this we have to prefix the name of the acyl group, prefix the name of acyl group, to the phenol. We have to put a word phenol, and before that we have to give the name of the acyl group. As for example, so name of the acyl group is aceto, so we will write acetophenol. Okay, then another, here the name of the aceto group is propionophenol, right? Another group we are talking, another compound, that is this 2-benzene ring in this ketone. You can say 2-benzene ring. So in this name is benzophenol, right? So this is for the alkyl phenyl ketones. Okay. So we understand the common names of the aldehydes and common names of the ketones. Now another thing that is the most important thing, and that is in terms of your exam, that you will learn very clearly, that is the common name. that is the IUPAC name. Common name we are already discussed. IUPAC name. IUPAC name. So first we will discuss IUPAC name, that is the aldehyde. Right? What is the IUPAC name of aldehyde? First, that it is basically derived from the name of the alkene from which this aldehyde has been prepared. As for example, this is the aldehyde, the simple aldehyde. The alkane from which this aldehyde has been prepared, that is naturally you can say there is a 2 carbon atom, means ethane, and this ethane word, E word, ending E word, we have to replace by L. So name of this aldehyde is ethanol, right? Another, suppose there is a substituent present in this aldehyde. At that time, how do we name this? Let us understand. Suppose in this position there is one bromine substituent. In this position there is methyl substituents, and you have to see, you have to make this bond 4. Carbon has a 4 bond. So this one hydrogen has been replaced. This here are being replaced. So how do you name this? Let us understand. Here there is a 2 substituent present, that is in this position and this position. For that, what we have to number the carbon atom. How do we number? From where you have to number? You have to number from the carbon atoms of the aldehyde group. Carbon atom of the aldehyde group is this, so you number from here 1, 2, 3, 4, 5, 6, 7. So first we have to prefix this substituent. Prefix, and that substituent we have to put in the alphabetical order. So alphabetical order, that we can write 5 bromo, 3 methyl. Then you have to give the name of the alkanes, that is, here it is heptane. So we write heptanal. L. We have to replace the E of the heptane by L. So this will be the name of this compound. Okay. Suppose there is a double bond present. Here you can see one double bond is present here. At that time, how do we name this? Again, we have to put this. So here the name of this paint, 2 number position there is a double bond, 2 in L. Paint 2 in L. Okay. And now we will discuss if this is a cyclic compound, cyclic aldehyde, means the aldehyde group is being joined to a ring. Ring may be benzene ring or maybe saturated ring. At that time, what will be the name? At that time, you have to give a suffix, that is carbaldehyde. As for example, this. Suppose this is A. So what will be the name? We have to write the full name of this alkene, that is here cyclohexane. Cyclohexane, and you have to full name. E word you have to retain here. Cyclohexane carbaldehyde. So we have to give carbaldehyde. Okay, cyclohexane carbaldehyde. If there is any presence, suppose there is presence a substituents NO2, at that time we will numbering this carbon atom from this carbon atom where the aldehyde group is attached. Here it is attached. So it will have the first number, 1 number, 2 number and 3 number. So we will write 3 nitro, that thing will be same cyclohexane. Okay. Now suppose this is a benzene ring. Here there is a presence of CHO. At that time what will be his name? This name will be benzene 1,2 dicarbaldehyde. Okay. So you easily understand how we can name the aldehyde in the different ways, the different compounds. For the cyclic compound, for the aliphatic chains, that is open chains. Okay, I think this is clear to you. Discuss the IUPAC name of ketone. Name of ketones. Like aldehyde, the name of IUPAC name of the ketone also derived from the alkane from which it is prepared, and it is been E ending E word has been replaced by ONE. As for example, this is a ketone. So here first thing that we need to understand, how do we number the carbon atom. We will number the carbon atom from that end which is nearer to this group, keto group, that is the keto group. So this end is nearer to this keto group, so we will make the numbering of the carbon atom from this end 1, 2, 3, 4 and 5. So what will be the name of this? This name will be that you have to see the number of carbon atoms. From this we will have the name of the alkane 1, 2, 3, 4, 5, that is the pentane. So we will write pentane, but E word we have to replace by the 1, but here the CO bond, CO carbonyl group is at the 2 number position. So we write pentane 2, 1. When you write this, you have to make this dash here. Okay. Now, second compound, suppose this compound, let us understand. Here you can see there is a substituent presence. Methyl group is present in the 2 carbon atoms, right? So how do we, first we have to number this. Here you can see both the ends is equidistant. If you take from this side or if you take from this side, does not matter. So suppose we are taking 1, 2, 3, 4, 5, right? So what will be the name? Let's see, there is a substituent is present in the number 2 position of the carbon atom or number 4 position. So we write it 2, 4 dimethyl 2, 4 dimethyl. Number of the carbon atoms 1, 2, 3, 4, 5. The longest carbon chain we have to consider, right? 1, 2, 3, 4, 5. 5 means paint. Paint, and the 3 number position, there is the group paint 3, 1. Okay. Now let us have the cyclic ketones. Cyclic ketone is this, suppose this is cyclic ketone, and here one position there is a methyl group. So how do we name it? Or the cyclic ketone, that is the same thing that applicable for the aldehyde, that we have to write the full name. Not full name, the E word we don't have to write for any alkanes. Full name of the alkenes excluding the E word, that is cyclohexane, cyclopentane, and this has been in the last we have to give the 1. Suppose what will be the name of this compound, that is cyclic compound, it will be, and the numbering of the carbon atom when that will be start from here also 1, 2, 3, from the position where the carbon atom of the keto group presence will start this. So name of this 3-methyl, name of this 3-methyl, that is 1, 2, 3, 4, 5 pentane 3-methyl paint paint 1. So this is the name of this 3-methyl paint 1. Okay. Suppose there is a double bond in this keto group is there, and also there is a double bond. At that time, how do we? First we have to number this carbon atom. So here you can write 4-methyl 1, 2, 3, 4, 5 paint 3 in 2, 1. Right? So this will be the 4-methyl paint 3 in 2, 1. So in this way we can able to have the IUPAC name, official name of this ketone and aldehydes. That is all for today's lecture. In this lecture we have discussed about the very basic thing in this chapter, that is the introduction to the aldehyde, ketone and carboxylic acid, and also discuss the IUPAC and the common name of this. This is basically a service to those students who could not able to afford the costly tuitions, and I think that will going to help them achieve their targets. Thank you very much for watching, and we will meet in the next lecture.